am Jeremy Rand. I go online as BioUser89. I'm a computer science major here at OU. My collaborator on this research was Martin Michelsen, who goes by the name Fuzziqer software online. He's at Caltech. So our research is on using video game enhancement technology to enable online play of modern offline multiplayer games. So we've been doing this research since roughly 2004 when we were high school freshmen, but this is the first time we're actually presenting this in an academic setting. So our research involves video game enhancement technology, and for those of you who are not familiar with that, it temporarily modifies the gameplay experience of a game without having any access to the game's source code. So usually this works by reverse engineering the game and using that knowledge that we gain to edit the game's memory as it runs. So stuff like Game Genie, Game Shark, Action Replay, if you've heard of those. So when we tell people we work in game enhancement, people often say, oh, so you're cheating at games. And we think that's kind of unfortunate that people associate game enhancement with cheating at games, because that you can do a lot more interesting stuff with that technology, rather than just cheapening games. So we think making games more innovative, more competitive, and more fun is what the technology should be used for. So we don't cheat, we enhance. Our work in particular focuses on online enablers, which are a type of game enhancer which allows multiplayer offline games to be played over the internet. It's innovative, competitive, and fun. So it's an example of what we think game enhancement should do. Now this is not really a new idea. There have been online enablers in the past. The first one that really came into existence was the X-Band, which was a device for the Sega Genesis, Sega Saturn, and Super Nintendo. It was a 2400 baud modem which patched compatible games to intercept two-player activity and redirect it to the modem, which enabled online play. It supported 38 games, but it was discontinued 3 years after it was introduced. Another type of online enabler is emulators. PCs can emulate older game console hardware. Some of these emulators have the ability to exchange controller inputs over the internet, which can enable online play. This works with any game playable in those emulators. It became popular in 2001 or so. A third type of online enabler that was already in existence was LAN tunnelers. And this works because some newer games support LAN play, and a PC program can rig up a network card so that the network card will capture and inject packets into the network to simulate another game console on your LAN. And if you send that via the internet, you can enable online play. The leading LAN tunneler, which is Kai, supports 704 games right now on 6 recent consoles, and they're adding new games as they come out that support LAN play. Here's the problem with the technology that was already in existence when we started this research. All three of the methods I talked about had some serious drawbacks. Emulation is expensive because recent consoles need a huge amount of CPU power to emulate. So a Wii will cost you about $150, but if you want your PC to emulate a Wii, about $1,500, and that's prohibitive for a lot of people who might want to play a game online. LAN tunnelers like Kai rely on the games having LAN functionality. Not all games do. In fact, only 3 GameCube games and 0 Wii games actually do. X-Band was a really cool idea, but it had some drawbacks also. It required major infrastructure requirements. Basically, this was before the era of cheap internet. This was the early 90s. They had to manufacture and distribute specialized modem hardware, which was a really huge investment for them. They were never really able to recover from that investment. And they had to have a team of really skilled employees who would individually reverse engineer each game and develop a patch for making it play over the network. They had a lot of games they wanted to support and not really enough reverse engineers to handle all of them. Because the connection was really slow, that made it even harder to patch the game so that the game was fun to play. And so these issues caused it to be abandoned before it was even 3 years old, even though it was a really cool idea. But we think the idea behind the X-Band had a lot of potential. So when we started looking at creating online enablers for the GameCube in 2004, and for the Wii in 2008, we considered how the X-Band worked and how we might improve on that model. The infrastructure issue could be solved just because modern networking allows you to do peer-to-peer connections, so we wouldn't need to maintain our own servers. And bandwidth and latency both improved on modern networks, so we don't need our software to handle 2400 baud dial-up connection anymore. We would need to use hardware that already exists because we don't have the resources to manufacture modems and sell them to people. And we wanted to make adding support for new games a scalable process. We want any user with moderate computer skills to be able to add support for a new game without our involvement directly. But, okay, so we found a solution for that in traditional game enhancers like Action Replay. Action Replay codes follow a fixed format of specified data to modify, and you can make Action Replay codes with very simple tools, often if you have no programming knowledge whatsoever. So we figured if we use the same format for the online enabler patches that the Action Replay codes already use, anyone who can make Action Replay codes can make a game playable online. So the first product we produced was GCARS-CS, that's GameCube Action Replay Simulator and Control Simulator. It's our GameCube online enabler. It implements an identical code format as the Action Replay codes and uses them to synchronize gameplay across multiple GameCubes. And because of this, a large existing community of Action Replay code creators can thus start making games go online. As an example, let's say you have an Action Replay code for player 1 in some game always having no damage. That's your code there. This exact same code will synchronize player 1's damage across all consoles with GCARS-CS. So basically, you can just copy and paste the codes from an Action Replay code creator application, or for that matter, a public cheat code database, and the game is playable online, assuming the code can create or find the codes. And we think this may have the effect of redirecting cheaters' efforts and skill sets toward more productive uses than, cheating. So how does GCARS-CS work under the hood? So we place a small 32 KB piece of software in the top of the GameCube's memory, and we instruct the memory allocator, don't touch that chunk. This piece of software, which we call the hook, patches the game to execute at every frame. This is how the Action Replay works as well, and in fact, an Action Replay master code is what we use to patch each game. We have an internal list of Action Replay codes in there, which includes codes for things like button and stick presses, players' XYZ coordinates, players' health, menu selections, stuff like that that's necessary to keep the game synchronized. And as each GameCube running GCARS-CS processes the script, which is the script is the code list. And as they process that script, it outputs the code list with the data that it read inserted. It outputs that over an Ethernet port that the GameCube has. And since we use the Ethernet port that Nintendo manufactures, we don't have to make our own hardware. Each GameCube receives the data sent by other GameCubes, and it runs that through its own Action Replay engine. And it writes the data to the game, just like if the data were read from a standard Action Replay code. So the GameCube stays synchronized. Now, there's that troublesome problem of lag. In the event that lag causes data to arrive late, after the next frame should be rendered, we have a few options. We could just pause the game until the data arrives, and that's actually what the GameCube LAN games do, and that's why those GameCube LAN games play so horribly when played over X-Link via LAN tunneling, because it has to wait for a 100 millisecond ping or so every 16 millisecond frame. And this video here is Mario Kart Double Dash being played over X-Link High, and as you can see, it's really slow. If you look at the counter there, it's only about 10% of full speed. So we decided, don't go that route. What we instead do is we use the previous frame's controller data, and we just resynchronize later, and we rely on of the data that's being sent, like players' XYZ coordinates to make that happen. This keeps it running at full speed and frame rate, unlike this video, but it means that the games could desynchronize if we don't send enough data. So occasionally, before we were synchronizing enough data, we would have cases where two game cubes would think they were on different levels, and that would not be good. So, sorry. There's one button there. There we go. So if you take a look at this video, look at how one of the players is reacting when he gets hit by the other player, shaking around a lot. So after we released the first beta of GCARS-CS, we did a lot of research into what's the best way to make it work with games. And the big focus was on Super Smash Bros. Melee, which was the #1 selling GameCube game. And initially we had a lot of trouble with it when we played it online. This would happen. Basically, player 1 would try to attack player 2. He would hit on his screen, but on player 2's screen he didn't get hit. So player 2 would think, I didn't get hit at all. Player 2's GameCube would keep sending XYZ coordinates at its player saying, I'm not moving because you didn't hit me. But since we're not synchronizing velocity, only position, on this player's GameCube, sorry, on this player's GameCube, we had the issue where player 1 would see the character flying away, but the data being sent would keep moving it back to its old position. You see this thing is rubber banding. And that's really not good. It makes it really unplayable. And that's partially because we're only sending some data. We weren't sending velocity. Also, we were synchronizing this at 10 Hertz, which was not enough. Here's another video. Notice that rubber banding is no longer present in this video. The way we fixed that was, we had a few ideas for how to fix it. First thing we tried was make every player's data that's being sent come from the same GameCube. So basically, in this case, player 1 is acting as a server, and all the other players just send controller data. Everything else is sent by one GameCube. This keeps them synchronized, but it means you have to ping your opponent before you see yourself move, which makes lag a lot more annoying. So that wasn't really optimal either. What we ended up doing was adding codes for the player's velocity, things like whether they're touching the ground, there's a variable for that. And by doing that, and increasing the update frequency to 60 Hertz, if you have enough bandwidth to handle that, we managed to get this gameplay, which is virtually lag-free and much more playable. Now, by the time we had this working for Super Smash Bros. Melee on the GameCube, the Wii had come out, and we received frequent requests to port GCARS-CS to the Wii. Unfortunately, the Wii did not support the GameCube's Ethernet adapter, so that made it completely unusable for GCARS-CS. So we were trying to think of ways, okay, how can we make this better, since we were having to recode stuff anyway. The first problem we identified in how GCARS-CS was engineered was the entire 32 kilobyte hook was hand-coded in PowerPC assembly, and most of that was network stack. And rewriting all of that for a different piece of network hardware was not really something we wanted to do. It was definitely not what we would call an easy proposition. Another issue was GCARS-CS outputted an entire list of action replay codes over the Ethernet adapter that were then processed by the other game. This worked, but it meant that if two different games if you had two copies of the same game, but they were different regions, then they had different memory allocation for different regions, so the games would be incompatible with writing to the wrong memory addresses. And that was especially bad for Super Smash Bros. Melee, because there were actually 3 different versions of it released in the US, as well as the European and Japanese versions. And they were all mutually incompatible. So we wanted to fix that. Last thing was the Wii blocks access to the Wii's hardware when you're in GameCube mode. So even if we were to rewrite the hook entirely to work with the Wii's network hardware, GameCube games would not be playable on the Wii using this, and we didn't really like that. So we were rescued from this when a new piece of hardware came out. It's called the USB Gecko, And basically, it implements a serial port via a memory card slot on the Wii or GameCube. And, sorry, I'm flicking things intentionally. This is much simpler to program than a network stack. It's just implemented a serial port. And the memory card slot is accessible from GameCube mode. So we thought this would be really cool to use. And as it so happened, one of the first applications available for the USB Gecko was a program called GeckoOS, which consists of a sheet program like Action Replay, and also have a remote debugger that used the USB Gecko to allow you to find your codes. And like I said, it's way easier to program for the USB Gecko than a UDP/IP stack. And one of the cool things about GeckoOS codes, unlike Action Replay codes, GeckoOS codes have a built-in special code type for embedding assembly code that interacts with your regular codes. So all we had to do to make this work on the Wii was we took the USB Gecko driver that's available, it's written in C, we compiled that into assembly, and embedded that into a GeckoOS code. And we mixed that GeckoOS code with another code that specified what memory addresses to download write to. And the PC client, which is not entirely finished yet, bridges the USB Gecko to the network. So that's our design there. And there are several advantages to this setup. Since we pass the player data addresses directly to the Gecko driver, we're not transferring the addresses over the Gecko, we're just transferring data. Which means, assuming you have the correct codes on each Wii, now different versions or regions can play together. And the really cool thing is we wrote less than 20 lines of assembly, because the Gecko driver and the C compiler took care of all the rest. And the PC side application was programmed in C++ because we didn't have memory limitations there. So here's the video of Sonic the Hedgehog. You'll notice player 1 is running around, and player 2 is going to start mimicking that action in 2 seconds. So we did this because GeckoTunnel has a much more flexible architecture than GCARS-CS does. Basically, all we had to do to make this work was we redirected the online play feature. Rather than talking to another Wii, we just had the data being written to a file on the PC. So we recorded the data being output by player 1, and then we played it back to player 2. As you can see, player 2 is doing exactly what player 1 did, even down to jumping and wording player 1. And this is really cool if you want to make a ghost file for your friend or race at your convenience. Another cool thing that would be really nice to do is this thing we call player multiplexing. We haven't done this yet, but it's in the works. The idea is, since the PC app keeps track of all of the player's data anyway, we don't have to actually show your Wii every player that's there. Let's say we want to have 8 players in a 4-player game. Since we know the XYZ coordinates of your player, we can only show your Wii the 3 players closest to you. And if, let's say you're in a first-person shooter, that usually works, because you're not going to see more than 3 people at a time anyway. And that would lead to some really cool features. I mean, who wouldn't want to play a game with more players than play sports? All right. One last thing that we are working with is using USB gamepads as sources for data rather than a file or another way. So you can use this to play GameCube or Wii games with a USB gamepad, or for that matter, anything that can emulate a USB gamepad. So Wii modes for GameCube games, VR gloves, voice commands, Connect 3D cameras, head trackers, or even EEG-based brain-machine interfaces. The EEG will cost you $200. It'd be kind of cool to make it so we have to concentrate intensely to accelerate in a racing game. Of course, you would need some kind of training to actually use it properly, and probably it's difficult. But It'd be cool. One last video here. This is, notice there's 6 players here, and 5 of them are jumping around right now. This is some late-breaking news relating to what we did with using USB gamepads to control the game. As you may know, I don't know if you've played Super Smash Bros. Melee much, there's a secret mode in there that lets you do 6-player matches. Normally it's 4. And the GameCube, of course, only has 4 controllers. So what do the last 2 players normally do? Usually they will be computer controlled. But if you use a USB gamepad and GeckoTunnel to write that data to players 5 and 6, you get control of the last 2 characters. And right now we only have player 5 working, player 6 is just sitting there doing nothing. And there are a few moves that player 5 can't do, but we will release this soon. And yeah, that could lead to some really interesting gameplay options. So to wrap up, here is a list of games which we currently support. Either GCARS-CS or GeckoTunnel supports these. Not all are completely playable with every feature, but we're working on it. The gamers among you may notice these are all GameCube titles. That's because the Wii's control scheme with the Wiimote is way more complicated, and while it should work with our code, it makes it harder to test. So we're working on getting GameCube games to work well on the Wii before we work on Wii games. Also, we only support the American versions right now. That's because the memory allocation thing I talked about, we only have access to American games because we live in the US. And they have different memory allocations, so you need different codes. But if any of you had access to European or Japanese games and are interested in helping us out with adding support for them, let us know. We'll try to help you out. This work would not be possible without a lot of people, so we would like to thank, in no particular order, Dr. Denver Tritton, Team Tweezers, Costas, Samsung, Titanic, GCLid, LiboGC, Parasite, Link, Kenobi, DCX2, Nuke, VRCurge, YS, WePower, James Oaks 57, Romap, Nutmeg, Safran, Team Xlink, Diffuse, Look, Copero, Psychotic Worm, Captain Brunch, Radio from FF2, Marty Rand, Brian Cluck, and Chris Boucher. So, thank you to everyone there. If you're interested in our work, if you want to try it out, maybe even add support for new games, you can find us at VECLabs.postgres.com, that's me, and FuzziqerSoftware.com, that's Martin. And the official forums for our project are on FuzziqerSoftware.com as well. Click the forum link. Beta testers, script authors, anyone else is welcome. And that's it. Any questions?